For finding solutions to our crisis. You know, but in Nigeria, I think that ẹ̀yin ò tilẹ̀ ẹ bàbá wọn ò ní ká yọ kálẹ̀. Oyin àtẹ́lọ́ bàbá ẹ ìjọba ló kò sí àwọn àwọn kéṣekéṣe lẹ́yìn.
Waterbury 1.5 is beneath the left ground level. The geophysical readings indicate fractured water over 45 to 55 feet depth. Drilling is advised to a minimum depth of 60 to 65 feet to fully penetrate the Waterbury fracture zone.
I'm happy to announce with the help of the AI survey app. They found the suffering water.
Thank you very much, and that was the performing art troupe of Kwara State University. They are made up of students of the Department of Performing Arts. And I would like to inform you also that this building is the Performing Arts Department building. It's dedicated to their department, and it is named after the pioneer Vice Chancellor of Kwara State University, Professor Abdulrashid Na'Allah. Thank you very much. And ladies and gentlemen, I would now like to invite the lead paper presenter and the person of Professor Taufik Adedosu from the Ladoke Akintola University of Technology, Lautech, Ogbomoso.
Good morning, all. All the duly observed. It has already been established. But still, I must specially recognize the Vice Chancellor of this great university, represented by the Deputy Vice Chancellor. Then again, I would like also to recognize the Dean, Faculty of Physical Science of this great university, the NAPE, indefatigable NAPE President, the NMGS President, and the Vices of NAPE and NMGS Presidents. Also, I would also like to recognize the UAP Chair, Dr. Obi, who has been performing wonderfully well. And the Dean of Faculty of Physical Science of the Loring, well-respected Professor Adekeye, and everybody here seated. Great Nigerian students. Great Nigerian students. You know, it's a great pity for me to be here to present the lead paper, which is titled The Molecular Fossils to Modern Energy, Petroleum Biomarkers as Tools for Petroleum Exploration, Environmental Monitoring, and Sustainable Development. Like we have already heard, my name is Professor Taufik Adewale, a professor of organic geochemistry and head petroleum and environmental geochemistry research group at the Department of Pure and Applied Chemistry, Ladoke Akintola University of Technology, Ogbomoso area. First of all, you know, we all know that energy is very essential. And that's why every day, that's why NAPE is thinking on how we are going to increase our reserves every day. Because as you know, that energy fuels modern economy, industries, and our daily life. There's still something comes with it. And that's why NAPE is not focusing on energy alone, because it comes at a cost, which is our environment. And that's why, and we still need to protect our environment, because our energy exploitation leaves footprints that must be and mitigated. Still, the society needs sustainable development. And the challenge, what's the challenge? The challenge is to balance between fossil fuels with renewable energy, global progress. But a knowledge gap exists. And what is that knowledge gap? That is, the public often feels fossil fuels and renewables as opposing forces, while experts see it as a continuum. At this junction, geoscience education is that thing that will provide that bridge. And at the heart of that bridge lies organic geochemistry. And this organic geochemistry deciphers the chemical fingerprints of ancient life, logged in segments and fuels. And here enters the key, petroleum biomarkers. And these petroleum biomarkers, they are molecular fossils that unlock vital stories. Number one, the source of oil and gas. They tell us the source of oil and gas, the environmental and climatic history formation, then of the role in guiding the transition towards cleaner, sustainable energy. So the storylines naturally flows. And how does it flow? From energy to environment, to sustainability, to gap, to geoscience education, to organic geochemistry, and lastly, to petroleum biomarkers. What are these petroleum biomarkers? These petroleum biomarkers, the organic compounds. They are organic compounds. But what makes them different is that they should have a precursor compound or a precursor organism in the geological environment. We should be able to trace them to a particular organism in the geological environment. And that's what makes them different. Majority of them, like I've said, the organic compounds. But there's an argument. What is the argument? Is polycyclic aromatic hydrocarbon. Are they part of them? Yes and no. Yes, in the sense that all the functions of biological markers, pH, we all, as is popularly known, the naphthalene of this world, the phenadrine of this world, and the likes, they perform that function. And again, as you all know, that when the heat is increasing, the biological biomarkers pushes out, they disintegrate. That is the time when pH will be forming. They perform all the functions of biomarkers. But the only thing is that up to now, although research is still ongoing, they have not been trained to a particular precursor in the geological environment. And that's why you see some textbooks, we refer to them as pseudo biomarkers. And that's why I said yes and no initially. How does these biomarkers perform their functions? They have some unique properties. And part of these unique properties is that they retain the sum of organism structures. They all exist as molecular fossils. They are unique oil source fingerprints. They track burial and eating history. They also serve as depositional environment indicators. Then also, they have a particular pattern that can reveal biodegradation. Then also we have their carbon isotopic signature. It can be carbon 13, it can be deuterium. And you can use this way to really know the source of this organism in the environment. And we have various examples, like the alkanes, the pristanes, the phytanes, the triterpenes. Those ones are the aliphatic, because normally we have 3 categories. Any fossil fuel, whether in liquid form, in solid form, have 2 different parts: the maltene and aspartame. The maltene is the soluble part, and this maltene, that is where we have our biomarkers. It can be in aliphatic form, like the alkanes and the pristanes and the likes. It can also be in aromatic forms, and these are the polycyclic aromatic hydrocarbons. They can also be in the polar form, which is the fatty acid, the alkanones. All these ones are examples of biomarkers, and we can make use of all these in both petroleum geochemistry, so make use of them to monitor the environment, and also to provide solutions to mitigate the environmental problems that may arise from petroleum exploration. Then also, we can also use of them bioenergy research. Biomarkers answer a very big question in petroleum exploration, because I will look at these 3 aspects very quickly. In petroleum exploration, we can use them to map hydrocarbon through time and space. They can also reveal oil origins, the measure richness, the track system maturity. Then also, they are also storytellers. Now, this storytelling, we'll look at, because we've worked severally in different basins of Nigeria, myself and my co-authors and my students. We will look at the Anambra Basin. We look at Ogu Formation. We also Chad Basin, basically the Tumawa and Wadi One well. And what are we trying to do? These are the whisper stories of origin, richness, depositional environment, and transformation. In the Anambra Basin and the Middle Basin Trough, problem statements. The problem statement is that we have fast petroleum trough codes. Then up to now, the petroleum potential unclear. There's limited geochemical data. But there are solutions, and the solution is the use of petroleum biomarkers to really know the petroleum potential of this the source rock. Then also the carbon 13 isotopes. And these are well implemented in some of our stations. My is at the University of title Organic of Nigerian coal as a petroleum source rock. This was in 2009. And then again, we have various publications 2010, 2011, 2012, 2015, 2020, and we are still publishing there. And what are the major findings there? Normally, what we do is that we did a SAR analysis, then we did biomarker profiling, then also we did carbon isotope, study of this. And majorly, we work on two different formations. We work on Ogu formation. We also work on marble formation. And in marble formation, we work on Onyama coal. Then we also on Kaba coal. And what we are able to discover from this wonder marker is that Ogu is thermally mature. Ogu, terrestrial dominant source with mixed magnitudes. Therefore, it has a good petroleum potential. While Mamu, especially Okaba, is still immature at the present. The one thing that is very peculiar to this Mamu is that, especially the Okaba coal, is that we are able to isolate some benefits from them. And this benefit will indicate oxygen environment. Then also, for the first time, we are able to isolate the 3 olefin isomers from Okaba coal. And this is well documented in Adekoshi 2010. And these are the various evidences that show that it is still thermally immature. We look at petroleum parameters, the aliphatic, the alkanones, the polar fractions. We also try to look at the PAH. Don't worry, because of time, I will drop this. I will donate this as a copy to NAPE, for your record purposes. Thank you very much. So, in the carbon-13 isotope, because probably the major problem with biomarker is that, especially when we take the normal things, normally we have from marine origin, then from terrestrial origin. There are two major regions. Then in between, we have that intermediate regions. There are ratings between carbon 20 to carbon 25. They normally indicate alkanes. There are times whereby when you run only the normal alkanes or the triterpenes, it will only show the terrestrial organic matter, the higher plants. But by the time you draw the carbon stone, it will be able to delineate between the terrestrial and the algae. So, and that's why there are times when we draw the isotopic composition. And from here, from the carbon isotopic composition, we are able to conclude that the Ogu is mixed but terrestrially biased carbon-3 plant waxes. So, to layman, what is the implication of that? The implication of that is that likely you can get gas from Ogu, but still, when we have some lacustrine environment from algae, you can still get oil from there. And when we talk about the Onyama, we are able to, from there, we are able to know that especially the Onyama coal is mature, it's also gas prone, and it has a limited oil. While the Okaba is of type 2 kerosene, but it's still immature for any reasonable, exploration. Then another one from there is the Chad Basin. And in Chad Basin, we work on Sumawan well and also Wadwan well. What's the problem statement here? The problem statement here is that despite extensive studies and decades of exploration, the Nigerian, that is the Borno Basin, the Borno arm of the, the Chad arm of the basin in Nigeria, which is Borno Basin, the hydrocarbon potential remains inconclusive to uncertainties in source rock maturity, kerosene type, and depositional variability. The biomarker has been able to provide answer to that. And from this work, I was able to supervise 3 MTech students and over 20 BTech students. Then also, we have publications, 3 publications well documented. Adedosho and Ogunbesan 2019, Adedosho Eto 2020, then Ogunbesan, Adedosho and Raji 2020 from there. And what are the major findings from this place? Because although the two of the wells, they are in chart basin, and majorly they have some common formation, still there are some differences from our studies. And from the tumor well, the biomarker characteristics indicate phytoplankton derived inputs, phosphate orders from oxic to anosic, hypersaline and reducing conditions with marine organic matter and type 2,3 kerosene, suggesting both oil and gas flow potential. While in Wadi well, it shows phytoplankton inputs, the stronger terrestrial influence with definitional conditions subbasic to anosic and hypersaline. However, there is a dominance of type 3,4 kerosene, which points mainly to gas-prone potential. There are so many wells that we carry out. We look at the both the aliphatic, then also we look at the aromatic hydrocarbon, in there. So that is for the petroleum potential. I told you that petroleum biomarkers, we can up it to monitor environment. So biomarkers, they are environmental detectives. They fingerprint oil spills. They can identify pollutants with molecular signatures. We can use them to track biodegradation, to monitor microbial breakdown of hydrocarbons. Then also to support regulation through scientific evidence for environmental tools to trace sources, processes, and impacts of petroleum potential. So they are very, they are very useful to know all this. And from some of our work that we do, I don't think that people should know. Because majority of people, when they go to the field, when the oil spills are reported somewhere, they go to the field, what the normally major one is to look at the melting parts. The melting part is a great problem because it's formed from the aggregate of molecules, a giant molecule. And I think I told them, in 2003 or so, I was invited by NOSBRA, to train for their staffs. And I told them that part of the problem you guys have is that when you go to the field, you are monitoring, you want to know, you want to remediate. You normally focus on the melting part with looking at the asphalting part. And the asphalting part is the most recalcitrant of all. And we did some work on it. And from there, we discovered that even from the asphalting, you will know whether an oil spill has been occurred or it has occurred a long time ago. And if the site has been remediated, you will know the percentage remediation from that place. And we try to do some work which are well documented. And we study some soil samples from Isoko North, Isoko South, from Igoni North, Ugeni North. And what we discovered from that soil sample is that we extracted the bitumen, we fractionated, then we run FTIR, we run GCMS on this. And we are able to discover that from Isoko North, there is highly weathered crude oil residues with mineral organic complexation. Then from Isoko South, it consists of biodegraded petroleum with oxygenated hydrocarbons. From Ugeni North, there is intermediate maturation with aromatic dominance, which shows that they are all polluted. And facial looking at them at times, you might not see the pollution until you run this, because this is a generic identification of the kind of pollution occurs. In fact, when you see the chromatogram, I don't know, I thought projector will be available so that people see all this. And when you see the chromatogram, you will see, in fact, you may taking them to the chromatogram of Niger Delta crude oil, and it doesn't stop from there. You can actually, again, from this place, you can actually know the type of remediation, and that's why the critical assessment is very important before you go into any remediation strategy. Because from the critical assessment of the impact of that skill, you will be able to know the adequate remediation that you need to carry out in there. Like the study that we did, we discovered for the one from Isoko North, we discovered that there is high concentration of labile hydrocarbons and low oxygen penetrations. For the other one, there is appropriate for semi-weathered residue, allows erosion and microbial simulation. And based on that, we have carried out so many tests. The biomarker profiling, we work on the aspartame content, and we are able to come up with this suggestion that if they want to be remediated, the first sample should use XC2 biofile treatment. While the other one is land farming plus nutrient amendment. Then the other one is bioventing plus phytoremediation. Then the last one is to use anaerobic bioreactor bioaugmentation. That's why I also told the Nostra people when I went there that anytime you want to constitute your research team, make sure that the junior scientists are among, because they are very familiar, they know the chemistry, they know everything about what is happening. So it's not only the Oyinbo that you just put. Make sure you include the indigenous scientists, because I can't say local scientists, because our scientists are internationally recognized, but they are indigenous scientists. So you should make sure you you include them in their money, in the remediation process. And so, like I've said, you can also use these biomarkers to trace the level of remediation. We also carry out some work. We use cow waste. When you see, in animal, especially the cow, you see that by the time they slaughter cow, there's some waste products inside that they will, those waste not really a waste products. We can actually turn them into something useful. And that's what is called cow remains. And we use it to carry out some studies. And from that studies, we are able to discover that we recorded around, after 28 days, we recorded around 95 degradation for our TPH, total petroleum hydrocarbon, the normal alkane. And also, for the aromatic, we are able to record something like 94% remediation. Then how do we know this? We use this biomarker to trace it. We look at the final, and you will see as the agitation is going on, the speed will be flattening. So, and from there, you calculate some ratio, the CPI of this word, the OEP of this word, the percent fighting ratio. From all there, you will be able to know whether you have been able to complete your remediation program. And the other one that people are not really familiar with is that, the other time when the NAPE president is talking, they are talking of transition, energy transition. So I want to tell you students here today that as a geoscientist, the honor lies you. It's not only petroleum. We are also finding solutions. All the challenges are arising from this exploration. We are also finding, we are the one to also find to it. And I'm very happy to tell you today that we have to also work on that. Also, we work on some underutilized plants, seed oil, the renewables, the G-melina. You see, G-melina is very popular around all these places. Normally, they use the leaf for ozone protection. So we don't work on the leaf. What we work on is the seed. And because it's not useful, it's not something that we take. So, and we are able to discover so many fantastic things. Although, and also, we also work on water hyacinth. In Yoruba, we call it Ujoro and Oshibata, the two of them. The water hyacinth of this world, and also the water lettuce, because they normally occur together. And we find a very fantastic result from there. How do we also run normally we pyrolyze between certain range of temperatures. And the oil we are able to get at the optimized condition, we take that oil. The oil is just exactly like our crude oil. after the priorities, after the optimum condition, and it's the one that we got at that optimum condition that we now run the DCMS. It's not direct, all the protocol of crude oil, we use it on it as well. We isolate, we fractionate, then we now run the analysis on the aliphatic and the aromatic. We didn't do the polar because we need to derivatize first, and the result is still ongoing in our laboratory. But the one that we got, it gives us a very encouraging result. And from there, we discovered that the oil gotten at this optimum temperature can be refined into transportation fuel, can serve as very good biodiesel. And as we know that we can have as something like energy mix, we can mix it with the fossil fuel biodiesel to get something fantastic. So you will now see that this biomarker is not only to be used to study, petroleum exploration only. We can also use it for environment. Then also we can also use it to achieve sustainable development. So what's the way forward? How do we bridge the knowledge gap? This will involve education and capacity building. And in order to prepare the next generation, we need a holistic approach that connects theory with practice. You see that is what people have been saying all along. Theory, practice. There mustn't be any disconnection. If I told you, when you see, you can easily identify a lecturer that carry out research very well from his lecture delivery. Because if we use all the results, all the experiences from the class and from the research to teach students. And in that way, there won't be any disconnect. So exactly what is happening with the theory is be able to solve it, to solve, practical, the human problem. So how do we go about it? Number one, we have to teach marker science in clear and applied terms. And that I will employ the NAPE that maybe probably there will be specialized workshop whereby the student will be taking through the practical skill of this biomarker, petroleum biomarkers. Then there should be hands-on lab and field training on GCMS, the isotope, the rock eval. And again, we should integrate geology, chemistry, environment, and sustainability. They engage students, community, and policymakers. And when knowledge is shared effectively, development is sustained. My conclusion and recommendation. The number one conclusion is that this one, they provide insights into hydrocarbon origin, maturity, and depositional history essential for petroleum exploration. Number two, they trace pollutant sources, assess contamination, and guide cleanup strategies. Number three, inform biofuel, biogas, and carbon capture studies, linking fossil and sustainable energy solutions. Number four, they integrate biomarker science into geoscience. We should integrate biomarker science into geoscience curricula to advance SDGs of clean energy, that's 7, industrial and innovation, that's 8, climate action, that's SDG, I think 8, then an ecosystem protection. What are my recommendations? The first one is educational integration, incorporating biomarker study into science, like I've said. Then again, research and collaboration is very key. Promote collaborative research programs between universities, research institutes, and industry to the application of biomarker tools in petroleum exploration. Again, technological advancement. This invest in modern analytical laboratories. I don't know how, because that's a challenge we face these days. I don't know how NAPE can assist us for us to have access to all the oil companies that has this improvement so that our students will be able to make use of them. Then again, continuous knowledge sharing like the one we are doing today. So we continue to upgrade ourselves. So in closing, our markers show us where we have come from. Light the path of today and dare us to shape a sustainable tomorrow. Let us rise and meet that future together. Thank you very much.
Thank you, Professor Taufik Adedosu from NAUTEC, our lead paper presenter at the 12th NAPE-NMGS mini conference. Please, another round of applause for him. I'd like to take this moment to recognize the presence of Professor Zacchaeus Okwafunsho from the Council of Mining Engineers and Geoscientists. You're welcome, sir. He is the registrar of the Council of Mining Engineers and Geoscientists. Thank you for coming, sir. Well, we will take a moment. I was informed that the president of NAPE, Mr. John Bosco Uche, has a presentation for one or two of our universities who are present here. No, he did not include the name of Kwara State University in his presentation. But we are gracious hosts, so we'll let us slide. Oh, we know he will see us behind the camera for our own. So let me invite the president of NAPE to the podium. I would also like to invite the representative of University of Maiduguri, Mr. Ibrahim Bashiru. If you are here, please make your way to the podium. Thank you.
Thank you. Okay. Thank you very much. So, just step forward. So before we formally present the workstation, just to give a bit of background so that we get the basis for what we're doing. So we have these workstations donated to us by SNEPCO, NNPC, PSC. And so what we did was to look at various regions to see how the university had been participating in the UAP program. And we selected one per region, per geopolitical zone. So for Northeast, it was very obvious that the University of Maiduguri has been very active in terms of the activities of the UAP. And it was on that basis that they were selected. For the North Central, if I'm correct, that should be the ABU, Zaria. For Northwest, that's correct. All right. So, but we have the University of Maiduguri right now, and we'll formally present on behalf of the NAPE leadership the workstation to help the university to further your research. I mean, we've heard the lead speaker speak about what we're doing. So with this workstation, we hope that you can do more. We also have the software to install with the Harvard Joe Solutions. So once you settle in, they should be able to install the software to allow you to even speak interpretation as the case may be. So we want to hand over the workstation to you, and I believe you are receiving it. But typically we donate it to the Vice Chancellor, who then takes it to the department. So you take that on behalf of the Vice Chancellor of your university, and eventually we believe your students will use this and prepare for basic evaluation competition that we do, the IBA, and hopefully your school will win that in the near term. So congratulations to you. Okay, so VP and PE can also join, and then Professor Adeke as well. And of course, the UMC. All right. So again, what this means is that if you work hard, it's going to be noticed, and there's always reward for hard work. And I want to believe that once we'll get to this point at some point in time. So we'll wait for the next, once ABU is here, then we'll do that second one. So thank you and congratulations on University of Enugu once more. Thank you very much.
Thank you very much, sir. We'll be taking a brief interlude. I can see some of our participants are moving out for their tea break, but as they're doing that, let's take 5 minutes interlude. Thank you.
láti NAPE àti NMGS lórílẹ̀-èdè àpérò tó ti ń ṣẹlẹ̀ ní yunifásitì yìí àti sórí ìlú fún Nàìjíríà. Ìṣàwọ̀ lẹ́yìn gbèsè láyé lágbára ọdún àtúbọ̀. President Nigeria Master Geosciences ní Nàìjíríà bí dáadáa àwọn àtúnyọ̀ ìṣàwọ̀ lẹ́yìn gbèsè láéláé lágbára ọdún tó ń pè ó àti ọjọ́ tó ní ìlàjì ìdìbò ìtumọ̀. Ilẹ̀ Igbo, that is why I sing that story for you. You are my in-law. That is to tell you I am an in-law in Imo State. Thank you very much. Mo ń lọ sórí Vicky Adéọ̀sùn látòkè ọ̀sán. Ẹkú orí kò ní burú kò ní ìbàjẹ́ lọ́dún tó kù. Ìdí Níbi tí aláàbò àti àjà yìí ẹkú ìjòkó ọmọ bí ẹkú orí sákì ọ̀sẹ̀ àti ìmúṣẹ́ ẹgbàá bí òkè ní títí Adéjẹyè láti orí Dáadáa ẹ̀yìn ń sáwé lẹ́yìn ìgbèjì láyé lágbára bàbá lókè. Ìdí ẹjọ́ ṣe ìwẹ̀ lọ́dún ní ìṣù. Ní sí ẹ̀ mọ̀ ní sáwé sí àti rẹ̀ nítorí ìpẹ̀lẹ̀ náà. Gbogbo ènìyàn ti ní àwọn ìgbàlódé tí mo àjàdí ìlọ́yà ìyọ̀ ìlú tẹ́tí yìí ìpínlẹ̀ ẹ̀dùn ọmọ ọ̀gbìn. Ajíbi kálàmọ̀ dámọ̀ lẹ́kọ̀ọ́ àríṣe kọ́ńtíkọ́ńtíkọ́ ọmọ ajíbi lórí ìlú àlá àjọ tí máa gbà nínú ìdúgbò ní ìlà báyìí nítorí ìjáde lẹ́yìn láàrin ọgbà èèyàn ní náírà mo ti fi ẹ̀ka akẹ́kọ̀ọ́ láti nígbà lẹ́yìn tí ìgbésẹ̀ yìí ìgbésẹ̀ ìdí ọlọ́dúnṣọ̀ náà máa ń jọ láti ilẹ̀ lọ ṣe orílẹ̀-èdè Nàìjíríà ó máa dáa tó. Association of Petroleum Exploration NAPE inú àwọn Nàìjíríà and Geosciences ní Nàìjíríà ẹ jẹ́ ká ṣepọ̀ yín kó máa lọ ní rẹbujú nínú àjọṣepọ̀ ní àfimọ́ lálàáfíà àfimọ́ nílọsíwájú lórílẹ̀-èdè wa kò ní burúkú ní bàjẹ́ fún alábàámu tó rẹ̀ ní tó láti yẹ ìlọrin yàrá èyí tí olùkọ́ta àlùkò nígbà tá ló wọlé òní fún àlùkò ibi tí lè kéré tí wọn sọ pé ìyáàdì kankan lọ láyé ká fídíò ẹyẹ tí ń ṣoge ìbàbá mi ti fún mi àsìkò ayọ̀ nípa àwọn ẹ̀kọ́ tó sọ̀rọ̀ títí mo ní àsìkò ayọ̀ orí àsìkò yóò sì kan tọ́sẹ̀ yín pẹ̀gàpẹ̀gàn ẹ̀rọ kọ̀ nìkẹ́ ẹ̀ má bàa yín lọ́rùn ẹgbẹ́ àti tí ẹ pẹ̀gàn a sì bàjẹ́ bẹ́ẹ̀ fẹ́ yẹn tiẹ̀ máa yín mú kálé ìgbàgbá ẹ ká lọ sí yunifásitì ti lọ kí gbogbo rẹ ti ṣe wẹ̀rẹ̀ tí wọ́n kúrò ní yunifásitì lọ́dọ̀ bí a lọ sí Ọbáfẹ́mi Awólọ́wọ̀ yunifásitì nífẹ̀ẹ́. Great, great. I love you. There is only one great event. And the universe, another great event is a fantasy. Great. I'm a complete great event. My body is great event. What is it? Great event. My PhD event. By introduction, I'm Dr. Hakeem Stobin, Faculty of Arts, Kwara State University, Manitou. Thank you very much.
Thank you, Dr. Hakeem Olawale. Well, let's say he's a celebrity here with us at Kwara State University. He never fails to deliver. So we only showcase him every now and then for our guests, so you know what we do as Kwara State University. He has trained a number of artists. When I mean artists, I mean students who have gone on to become professional chanters, and they are doing well with the outside world. Yeah. So please let's give him another round of applause. And like they say, once you are Ifeite or something, you are forever a person. So they're always so proud of their university. But I believe you will agree with me that Kwara State University is also a very beautiful campus.
Yeah.
Thank you for coming. I know you've had a wonderful time and you will enjoy the rest of your stay here with us at Kwara State University. We'll be taking a brief interlude. DJ, please music while we wait for the other participants to join us so we can conclude this part of today's program. Thank you all once more.
Am I gonna hear with DJ Expensive? So right now. Another person with another name. That's the devil. Yeah. And that's why I'm sure that from opening, I'm actually pushing the back, I consider only, yeah, probably not really for not really, yeah, it's just that's what I'm doing.
Well, ladies and gentlemen, as we are taking a brief break for the tea break, some of the students have gone out. We're expecting them to come back into the hall. Once they do that, we will take the brief induction talk from the registrar of COMED. The registrar is here seated. He's waiting for the students to resume back to their seats. And once they do that, we'll be giving him a few minutes to go through his talk, and then we will conclude the first portion of today's program, and then we can break for the Jumat prayers before we reconvene for the other portion of today's program. Thank you.
She knew, and she saw that I was so excited to see her here. I'm also delighted to see the president of NAPE, John Bosco. We have been talking, and he said the talk will continue and will crystallize soonest. All my colleagues and senior colleagues on the IPO, I appreciate the good work that you are doing. And also appreciate the leadership of WASU. I've been here one or two occasions for accreditation, for keeping your campus still beautiful. So I'm glad to be here again. My talk is about CSI. CSI, and I will be glad if all the student comes in, because when I take questions, then every one of you will know what we are doing to be able to propel our profession to the next level. Right. CSI is COMET Student Induction. COMET Student Induction. It's been on the drawing board for a long time. But I want to thank you for accommodating COMET for the first time to come and deliver a talk to our vibrant and young geoscientists and mining engineers that are hereby present. COMET is the only regulatory agency in the extractive industry that will enable you to get registered and certified as a professional to be able to. COMET Act number 40, Decree number 40 was signed in 1990, but was recorded or recapped in 2004. So been in the system for several years now, over 3 decades. But unfortunately, majority of students are not aware of the existence of your regulator after you finish your NYC. So, but that's not why I'm here. Why I'm here today is about the topic, bridging the knowledge gap. That's where my own will stop. The other one, they will take over the technical presentation. And they have started work today. So one of the ways to bridge the gap is this CSI, which I call COMET Student Induction, to create awareness on what they need to do after your degree, which represent the theory and the fieldwork aspect. And then bridge it with the practice where you'll be certified to go and work and earn an income. Without registration with COMET, Section 17 sub 1 and 2 of our Act says that nobody, a foreigner or a native or a national, should work and earn an income at the federal, state, and local government level, even in private, without being registered. So one of the first steps to be registered is this CSI, which is COMET Induction. And we are glad that we are talking about it at WASU for the first time during the 12th NAPE-NMGS NAPE conference. And there are conditions you need to fulfill to be able to be inducted as students, not as a certified practitioner. The first one, your name must be on the graduating list in the department. Your name must be on the graduating list. I'm coming to the other profession or regulator that are doing induction as of now. And we have obtained the permission of the board to be here to go on with this. Your board is represented by the Honorable Minister for now. You must be a graduating student, and the department will determine that. Because we won't wait until the Senate approves your result. Some of you will have gone outside the campus, bringing you back will be very difficult. The other condition in line with our act is that you must be a student member of NMGS. And the cost of the form is 1,000 naira. It's also desirable that you are NAPE registered. The reason why I'm saying this is that these two bodies, will be invited to the induction ceremony. And from there, you start to know what you need to do immediately after graduation. That these are the professional body that will bring you up. Bridge the gap before, the gap that exists from what we have taught you in the university. And of course, what you need to know in the field. And from now, you must identify with them beyond this medical. So what is the nature of this induction? And I want to say loud and clear. It is student-based and 100% organized by students. It's not university-based or university-sponsored. But university will be carried along. It's supposed to come up during your signing out ceremony. Every graduating student, each department organizes what is known as signing out. I think it's a week. And that is when the induction is supposed to come up. And the dates and venue will be determined by the students. Some of you have NMGS branches in your departments. Some of you have geophysics students in your department. Wherever there are two departments that falls under COMEC jurisdiction, the two departments will organize the program at the same time, the same thing, the same cost. And the possible days is within 30 days after your final second semester. That period within that, when you are doing your thesis, you are submitting the final copy and a few other things. We have visited some universities to sensitize them. Around here, we have University of Ilorin. I'm glad the dean is here, he's one of us. Visited Malete, Professor Jadi has attended to us. We have talked to another lecturer at Al-Hikmah University. I personally visited Lautech yesterday for the same purpose. The letter for this induction will be written by students, the president and the secretary, through the HOD to government register. And you are supposed to have two sponsors among your lecturers who are government registered. They are going to guarantee you with a beautiful write-up that your good behavior will satisfy you, so that, of course, that gives you some benefits that I'm going to talk about later. Then during the ceremony, the Vice Chancellor will be invited, DPC, deans, and a host of other industry practitioners near you, FMO, MCO officials they are around, and a few others. And like I've said before, representative of NAPE-NMGS will be present, and of course, representative of NAPE. The president is here, hearing me loud and clear now. We have not got a very firm, solid relation with NAPE. We want to start from here. NAPE president is shaking his head now, because we have talked a lot that talks will be over. We should go into action now. We are scientists, and then we should take action, and the action should be immediate. Then, what is the commitment of COMEC? Before I come to your own benefits, we are going to get approval for your induction from the board. We are going to attend the ceremony at the venue determined by the department and approved by the university within the campus, not outside. Then it will be carried out only in a department that is accredited by COMEC. If your department is not accredited by COMEC, forget it. We have the list of all departments that we have accredited. If your own is due, we are going to remind you. And of course, we'll follow up on that. Then we are going to present you a CSI certificate printed by Government Security Printing Organization, the one that prints your Naira. And each inductee will be entitled to that certificate. That's the only payment you make to Kume, which is 25,000 naira. And it's payable to TSA. You don't pay to individual. You pay to treasury single account. That is FG. Under the name of Kume. Now, before the benefits, which I know some of you will be eager to learn, who are the other regulatory agencies that have started induction year before now? You have Nigerian Medical and Dental Council. Some of you are familiar with them. You have a Pharmaceutical Council. You are familiar with the operation. Nursing and Midwifery Council. You are familiar. Correct. You are familiar. And of course, I think laboratory tech. Something similar like that. A few others I cannot mention. So what are the benefits to you? If I didn't join, what will I miss? If I join, what will I get? And that's why I want them to get in so that we don't have repeated questions. If we preach knowledge for inductee between theory and practice, it becomes easier to you to relate with the practitioners. It becomes easier for you to relate with the professional body. I've mentioned the NMGS and of course, especially good like NAPE, and relate and know what government is doing. Because at each occasion, we are going to tell you the level of achievement we have made. How do you key to it? What are the job opportunities here and there within and outside Nigeria? Then, the moment you are registered with us, of course, during the provision from 50% of the exam. Our exam is 2 hours, but you'll be exempted from the general paper. You know general paper now. What's the name? With that pay that will satisfy NMGS you register your relationship with us. So you only write the professional exam. And why? Because that would know the able to know how to certify it. As a geologist, geophysics, mining, petroleum, water resources, mining. Etc. etc. Get panic on Friday before the Saturday. Our exam holds every first Saturday of October. If you are registered with Come and show your certificate, you can send your technical paper online and we do a right interview for you before the exam. So you can only come to the exam that day on Saturday. Do your exam 1 hour and go. A year after NYC, unlike others that will be 2 years after NYC. These are the benefits that we have mapped out for now. More. This is the offer. And we have an agreement with selected university here. Around here, where we are going to start. We are starting from the right of which to discuss with them in the East. So this is the procedure, this is what we call school student induction. I thank the organizer for these 2 minutes and I appreciate if I'm allowed to take 1 or 2 questions from students before we round up. Thank you very much.
Thank you, Registrar Kumek. Professor Zacchaeus Opafunso, I'd like to quickly take that. If you have a question, please raise your hands and we'll take the microphone to you. Okay.
Thank you so much, comment Registrar. The question I want to ask, I know one of the restrictions with comment is a membership of the NMGS. So does this students registering 1 year after their graduation, it presume that all students are registered before they graduate? Well, those who have not registered with NMGS as students, does it mean that after 1 year, their graduation?
As a student, before you graduate, you